Very good morning. This is Dr. Manjunath Channapur from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed about what is Otto cycle, what is steam engine, what is the difference between steam engine and Otto engine, why the engineers they invented the Otto engines or compact engine or compact source. Then what are the drawbacks of steam engine that we have discussed in detail in the previous video. So now today I will move towards next topic. So again continuation of Otto cycle only. We discussed the history of Otto cycle, steam engine. Okay, the difference between Otto cycle and steam engine we discussed. Okay, now I will move towards next topic. Okay, the Nicholas Otto invented the four-stroke engine, that is gasoline engine. It is invented by what? Gasoline engine or Otto engine is invented by Nicholas Otto. Okay, fine. While his research journey or invention journey or in his experimentation journey, he understood some basic principle of Otto engine. So he understood some basic principle as I told in the previous class. What are the basic principles? So compression will be there, heat addition will be there, expansion will be there, heat rejection will be there. So he understood these four processes. Based upon these four processes, he developed in a cycle. Later, that cycle is used to develop the Otto engines like cars or bikes or something else you can take. So now he has developed four processes. He observed four processes and he understood four important operations that he explained well in his invention. What are those four processes that you can see now? One is adiabatic compression, isochoric heat addition, adiabatic expansion, then isochoric heat rejection. These are the four processes of four operations which were observed by Otto during the development of Otto cycle. During the development of Otto cycle or four-stroke petrol engine. Okay, these are the four processes he has told. Fine. So now what is first one that you can see here now? First one, what I will do, I will go with the adiabatic compression. So dear students, assume that piston is at particular point that I will explain in detail in upcoming slides. So piston is at this, assume that piston is at this particular point that we can call it as a BDC. Then it is having one more point that is a TDC. BDC is a bottom dead center, TDC is top dead center. So during compression, assume that during suction the air fuel mixture is sucked into the cylinder. Both inlet and outlet valve remains closed. Now assume that piston will start to move from BDC to TDC. Then what happens? The piston movement will takes place. Once the piston movement takes place from BDC to TDC, whatever the air fuel mixture is there, right, that will be get compressed. But how it is compressing, the air fuel mixture is getting compressed, but there is no heat transfer at all. From system to the surrounding or from cylinder to the surrounding, but compression is taking place. That process we can call it as a adiabatic compression. The piston movement takes place from BDC to TDC, air fuel mixture gets compressed, but there is no transfer of heat from system to the surrounding. That process we can call it as a adiabatic compression. Due to compression of this air fuel mixture, the temperature of the air fuel mixture which is there inside the cylinder is getting increased. The temperature of the air fuel mixture gets increased during compression. Not only temperature, pressure also gets increased. During compression, pressure and temperature both get increased. Now assume that the piston is at particular TDC. The air fuel mixture is already compressed, temperature and pressure is increased. At that moment, what he tried, that Otto, Nicholas Otto, he tried to supply heat. Then how he tried to supply heat? With the help of a spark plug. He has taken a spark plug and he given some ignition to the air fuel mixture. Now what he has done, he has taken in a spark plug. Dear students, you can take, here it is a spark plug. With help of this spark plug, already the piston is at this particular point. Mixture is already gets compressed, temperature as well as pressure is at high. At that moment, what he has done, with the help of spark plug, he ignited some ignition to the air fuel mixture. Then what will happen? Immediate combustion will take place. Suddenly combustion will take place. Once the sudden combustion takes place, what happens? The pressure is going to rise. That means there is a rise in the pressure. Not only pressure, temperature of the air fuel mixture also gets increased suddenly. Pressure is raised, temperature is also raised. Because of that sudden rise in pressure and temperature, what happens? The explosive force is going to create over the surface of the piston. Hence what happens now? The piston will start to move downward from BDC to TDC. Because of the explosive force, the piston will start to move from TDC to BDC. If the piston moved from TDC to BDC, the piston is moving from TDC to BDC, right? That process we can call it a expansion. During this expansion also, there is no heat transfer at all. When the piston moved from TDC to BDC. That process we can call it as a adiabatic expansion process. Adiabatic expansion process is a process in which the piston moved from TDC to BDC, where there is no any amount of heat is transferred from cylinder to the surrounding or from system to the surrounding. That we can call it as a adiabatic expansion. So what actually happened here now? Piston moved downward. Once the piston moved downwards, that piston is connected to crankshaft with the help of connecting rod. Now we are going to get some amount of work at the crankshaft. That work we can call it as a work on crankshaft. But during this expansion process, the temperature is going to decrease. This is the second operation he observed. Third one. Then fourth one, once the work is done, he is going to open the exhaust valve. Once the exhaust valve is opened, the hot gases, whatever it is, right, after burning, the hot gases which is present inside the cylinder, it will try to come out. That means heat is getting rejected from system to the surrounding, or heat source to the sink. That is nothing but what? That if the heat is getting rejected, that process we can call it as a heat rejection. How the heat is rejection is taking place? At constant volume. Heat addition also takes place at constant volume. That is very, very important. This process, this Otto cycle itself, we will call it as a constant volume process. Okay, heat addition as well as heat rejection takes place at constant volume. Fine. Now heat is getting transferred from system to the surrounding at constant volume. For that purpose, we will call it as a isochoric heat rejection. In this process, what actually happening? Exhaust valves are getting open. Then gases will try to expel from the cylinder to the surrounding. After that, after removing all hot gases from the cylinder, what happens? System is going to return to its initial state. This is what fourth operation what Nicholas Otto observed during the experimentation in the 4-stroke petrol engine. This is how it works actually. What are the 4 processes? Now I will move towards next topic now. So now I will move in continuation to that Otto cycle itself. You can see now Otto cycle, what he has done already. In quick recall, just you can see here now. Quick recall. Isentropic compression, what actually happened? Initially, the air fuel mixtures are taken into the cylinder through inlet valve. After that, both inlet and outlet valves are closed. The piston will try to move from BDC to TDC. What happens? Whatever the air fuel mixture is there, right, it gets compressed. When it gets compressed, volume of the gas is going to decrease, whereas temperature and pressure, they are going to increase during the compression. But there is no heat transfer at all. For that purpose, we can call it as a adiabatic compression, we can say. This is the first process. Second process we understood. At constant volume, assume that now the piston is reaches the TDC. Okay, that volume remains constant here now. Okay, at that moment what you are doing with the help of spark plug, what you are doing with the help of spark plug, you are going to give an ignition to the air fuel mixture. Then what will happen? Sudden combustion will take place, because petrol ignition, flash point and fire points are very less. If you are supplying a small ignition to the air fuel mixture, then what will happen? Sudden combustion will take place. If the sudden combustion takes place, what will happen? There is a sudden rise in the pressure as well as the temperature. Hence, what happens now? The explosive forces are going to create over the surface of the piston. Hence, the piston will start to move from TDC to BDC. That is nothing but what? Expansion. Sudden. If it is happening sudden, that we can call it as a isentropic expansion. But that expansion is how it is now, adiabatic only. Why it's so? Because during piston moving from TDC to BDC also, there is no heat transfer at all. That is nothing but what? Adiabatic expansion. If the piston is moving from BDC to TDC, if BDC to TDC, that is compression. If there is no heat transfer, then that we can call it as compression, adiabatic compression. Okay, fine. Now, so if it's so expansion here now, what is expansion? Piston is moving from TDC to BDC. There is no heat transfer. That we can call it as a adiabatic expansion now. Now, what actually happening now? Explosive force is going to create on the piston. Piston is moving down. Hence, work is done on the piston. When the piston moved from TDC to BDC, temperature is going to decrease. This is what? Third operation we know already. This is third operation. Fourth option is what? The heat. Once it's done, right? This is the BDC. Then exhaust valve we are going to open. When we are going to open the exhaust valve, the hot gases which is going to come out from the cylinder. Then that means what? At constant volume, heat is getting rejected. That means what? Exhaust gas is coming out. That means what? The heat is rejected at constant volume. There afterwards, what happens? Cycle is going to reset its original position. With the help of these all the process or operations, what we can do? We can calculate the efficiency later stage. Okay, dear students, now we can see what is that schematic diagram. With the help of schematic diagram, you try to understand the working principle of four important operations of the Otto cycle. With the PV diagram, you can understand better of these four processes. How it is that you can see now. Now I will come with what? First one only. Just a minute. Okay, fine. Now you are telling isentropic compression or adiabatic compression, because there is no heat transfer at all, but compression will take place. So dear students, you can see here now, this is a point one. So you are going to start with, this is a cycle. You can start from any point and we can end at any point, but both starting and end points should be identical. That is what cycle we know already in thermodynamics. Fine. I will start with this point one, that is compression. When the piston, assume that, dear students, there is a TDC and BDC. The piston orientation may be vertical or horizontal, but here I have taken horizontal, but here I have taken as a vertical now. Now assume that this is our TDC point, this is our PDC point. Now assume that piston is initially at this particular point, that I will call it as a point 1. Once the piston is getting compressed, so when we are going to put work on the piston, right? Piston, what will happen? Assume that inside the cylinder gas is there. Okay, gas is there. Once the piston start to move from BDC to TDC, whatever the air fuel mixture is there inside the cylinder, right, that will be compressed. Now assume air fuel mixture is there, piston is at TDC, it will start to move from BDC to TDC and it reaches the TDC. That means what? Air fuel mixture gets compressed. Air fuel mixture gets compressed, but there is no heat transfer at all during this process. That we can call this a adiabatic compression. But initially, when it is at point 1, it is having in a volume V1. When it reaches point 2, the volume become decrease. That volume we can call it as a V2. Whereas when the piston moved from TDC to BDC, volume is changed from V1 to V2. I mean, what I can say, volume increase from V1 to V2. And there is no heat transfer at all during this process. That is Q equal to 0. But temperature initially it was T1, but when it reaches point 2, temperature is T2, because T2 is greater than T1. That is fine. So that I have marked it here now. Once it reaches the TDC, right, then what we will do? At point 2 to 3, we are going to add some amount of heat. How? With the help of spark ignition. Spark plug ignition, we are going to supply heat to the air fuel mixture at constant volume. See here, now when we are at constant volume 2 to 3, the volume remains constant. When the piston is at TDC, that means what? Volume remains constant. Here V is constant. At that constant volume, what we are doing, we are supplying certain amount of heat. That is nothing but what? Heat addition or heat supply. So heat supply takes place at 2 to 3. That is nothing but what? Heat supply. So second process we can call it. First one is compression. That is okay, fine. 1 to 2 is compression. First process, that is adiabatic compression. After that, what we are doing, we are going to supply certain amount of heat to the engine at a heat to the air fuel mixture at a constant volume. That is what? Heat supplied. That is nothing but what? Constant volume heat addition. That is what? Second process. Then third one, once it done, right, then what will happen? Spark plug you given, heat you have given, then what will happen? Sudden expansion will takes place. Once the sudden expansion takes place, that means what? Explosive force is going to create over the surface of the piston. Hence the piston will start to move from TDC to BDC. So TDC to BDC, here what I will do, 1 and 2 I have taken, right, then I will take another points 3 and 4. The piston will start to move from 3 to 4. 3 to 4. 3 to 4, 5. So that 3 to 4 means what? Expansion takes place. The piston will start to move from TDC to BDC. That is nothing but what? Expansion. There also there is no heat transfer at all. That process we can call it as a adiabatic expansion. That process we can call it as a adiabatic expansion. That is what? Third process. Once it done, then what we are going to do now? We are going to open the exhaust valve. When we are going to open exhaust valve, at what will happen? Heat is going to getting reject when the hot gases is moving from piston to the surrounding. That means what? Heat is getting rejected at a constant volume. When it reaches, right, then you are going to allow to move the exhaust gas from cylinder to surrounding. Hence the heat is getting rejected at a constant volume. That we can call it as a V4 is equal to V1. P4 is equal to V1. That I have written. This is what now 1 to 2 adiabatic compression, 2 to 3 heat addition. Just a minute. Fine. So what is this? 1 to 2 adiabatic compression, 2 to 3 heat addition, 3 to 4 adiabatic expansion, 4 to 1 heat rejection. So this is nothing but what? Otto cycle. This is nothing but what? Otto cycle. This Otto cycle play a very important role for us to design Otto engine or 4-stroke petrol engine or gasoline engine. Okay, fine. That is nothing but Otto cycle. So the Otto cycle help us to design 4-stroke petrol engine. How it is? Now it help us to design, just a minute, design petrol engine, 4-stroke petrol engine. Okay, how we can design? We can design the petrol engine or diesel engine, not diesel engine, petrol engine or Otto engine by calculating the output power of the engine. With the help of the cycle, I can calculate the output power and how much fuel it is going to consume. That also I can calculate with the help of a cycle. Then I can predict the emissions from the Otto cycles. These all things we can calculate. Based upon this calculation, I can design the engine, Otto engine or 4-stroke engine, 4-stroke petrol engine. That is the importance of Otto cycle. Not only this engineering design, we can calculate the efficiency of the engine by calculating the compression ratio and combustion efficiency. To calculate this compression ratio and combustion efficiency, I can use this Otto cycle. Based upon that compression ratio and combustion efficiency, I can calculate the overall thermal efficiency of the engine. Okay, and also I can predict the performance optimization. So performance of the engine, SI engine or petrol engine can also be calculated by calculating the ignition timing and air fuel mixture. So to do these all things, engineering design, thermal efficiency calculation, performance optimization, so Otto cycles play a very important role in the 4-stroke petrol engine. This is how the operations, 4 operations play a very important role into the engine design, that we can understand. So that is what Otto cycle. Now Now, how it works Otto cycle? That you can quick recall. You can see here now. Isentropic compression. So initially assume that, dear students, here I have taken one more diagram. 5 to 1 is a compression. Sorry, here is this is what suction we can call. 5 to 1, 5 to 1, the air is gets sucked. Air fuel mixture is gets sucked into the engine cylinder. So we will start at point 1. So point 1 to 2 is what? Isentropic compression. Isentropic compression. Then when it reaches point 2, the piston is moving from BDC to TDC. Hence the volume decreases whereas pressure is increases. So from point 1 to 2 is adiabatic compression or isentropic compression we can call. At point 2 to 3, this is what process 1. Then what at 2 to 3, what we are doing now? At 2 to 3, we are going to supply certain amount of heat. That means what? That heat supplied is represented as QH, QS or QA at constant volume. At constant volume, heat is supplied to the engine now. Once heat is supplied, then what happens now? Expansion will takes place from 3 to 4. From 3 to 4, that expansion we can call it as isentropic expansion or we can call it as adiabatic expansion. There is no heat transfer at all. The piston is moved from TDC to BDC. That is what? Expansion. That is 3 to 1 to 2, 3 to 1 to 2, 2 to 3, 3 to 4. 4 to 1 is what? This is what? This is 3 to 1. 1, 2, 3, 4. 3 to 4 is what? 3 to 4 is what? Adiabatic or isentropic expansion. Once expansion is done, what we are going to do? 4 to 1. Then we are going to open the valve. The exhaust valve when we open the exhaust valve, exhaust gas is coming from cylinder to the surrounding. That means what? Constantly heat is getting rejected. The heat is rejected at constant volume. That we can call it as a 4 to 1. But dear students, we can see here now, very important. You are removed heat from the engine at constant volume. That means what? You can see here now. That means by seeing the PV diagram itself, we can see here very clearly the where V4 the volume of PK, because this is a P, vertical pressure, horizontal axis volume is there now. When we are going to draw a vertical line where V1 and V4 they are going to lies on the same point. That means what? V1 is equal to V4. That means what? They are constant. At constant volume, what you done? You rejected the heat. Similarly, you can draw a vertical line here now. When we are going to draw a vertical line, because horizontal axis represents volume, when we are going to draw a vertical line, V2 and V3 they are going to lies on the same point. That means what? V2 is equal to V3. Again, that means what? At constant volume, what we are doing? We are going to supply the heat. That means what? Constant heat supplied. Heat supplied at constant volume, heat rejected at constant volume. These are the 4 important operations which are understood by Nicholas Otto. So what are those? Adiabatic compression. And one thing, adiabatic compression, what happens? Air fuel mixture gets compressed. Okay. Then adiabatic expansion, compression. Then at constant volume you are going to supply heat. That is constant volume heat supplied or heat addition. Because of that heat addition, expansion will take place. There is no heat transfer. That we can call it as a adiabatic expansion. Once the adiabatic expansion is done, that means work is done, the exhaust valve is we are going to open. Once the exhaust valve is open, the heat is getting rejected at constant volume. That is V equal to constant. Hence that we can call it as a constant volume heat rejection. These are the 4 operations we are having in Otto cycle. These are the 4 processes we are having in Otto cycle. 4 processes or 4 operations in the Otto cycle. The Otto cycle. So during this adiabatic compression, expansion, heat addition and heat rejection, the pressure, temperature and volume, they are going to vary. How they are going to vary, that we will see here now. Now, so dear students, as I told, you can see here now, you can take this diagram or you can take this diagram now. Okay, now assume that you are at point 1. Okay, at point 1, when you are moving from point 1 to point 2, the volume, what actually happening here now? Here you can see now horizontal volume is more. When you are moving from point 1 to point 2, what actually happening now? Air fuel mixture is getting compressed, but compressed, and volume is going to decrease. That volume is going to decrease, or we can call it as a reduction. At process 1 to 2, or a first process, that is adiabatic compression, volume decreases. When air fuel mixture gets compressed, volume decreases, it's fine. What about temperature? Temperature is going to increase. It is in the first process. Volume decreases, temperature increases during adiabatic compression. That is one process 1. Second one, you can see now, second one, 2 to 3. Now you are going to move 2 to 3. What happens now? In the 2 to 3, when you are going to supply heat to the air fuel mixture, the already compressed air fuel mixture, then what happens now? Pressure is going to increase, temperature is also going to increase. During heat addition process at constant volume, pressure increases, temperature increases. One thing. Now process from 3 to 4, from the process from 3 to 4, piston is going to expand, where what happens now? Now you are at this particular point, right? That volume is going to decrease. Yes, sorry, when we are moving from point 3 to 4, that means what? You are at point this point, and you are moving to this point. That means what? Volume is going to increase. Yes, there is an increase in volume. What about temperature? Temperature is going to decreases. In the adiabatic expansion, volume increases, temperature decreases. Fine. Volume increases, temperature decreases. Fine. At the last process, from 4 to 1, heat is getting rejected. In the heat getting rejected, then what happens now? Heat is transferred from system to the surrounding, or piston to the surrounding at constant volume. One thing, what happens now? Once the complete hot gases, they are moved from the cylinder to the surrounding, then what happens? The temperature, what? It is going to retain its original. That means what? Initially it was ambient temperature, then it is going to attain its ambient temperature. Hence it is going to retain its original temperature before when it was when it was at initial condition. So these are the 4 processes. In these 4 processes or operations, the pressure and temperature, volume, they are going to vary for a particular process that we have studied. Okay, fine. Now with the help of these 4 operations or process, we can calculate the efficiency of the engine. To calculate the efficiency of the engine, we require work done. That work done also we can calculate with the help of this Otto cycle. And how much amount of heat supplied, that also we can calculate with the help of this Otto cycle. Okay, this is the importance now. Okay, now in quick recall, what actually happened? Process 1 to 2. Process 1 to 2 is what? Adiabatic compression. Next, 2 to 3. 2 to 3 is what? Heat addition. Next, 3 to 4, adiabatic expansion. 4 to 1, 4 to 1, constant volume heat rejection. These are the 4 processes. Those 4 processes we can express in TS, in terms of TS diagram also. Here it is a temperature versus entropy diagram. 1 to 2, 2 to 3, 3 to 4, 4 to 1. 1 to 2 is compression, 2 to 3 is 1 to 2 is what? Like that you can see here now. 1 to heat supplied. Okay, here it is a compressed, and for air compressed air fuel mixture, what we are doing at 2 to 3, you can see now heat addition we are going to do. 1 to 2 is what? Compression, that we already know, adiabatic compression. Then 3 to 4, what actually? Expansion is going to take place. Sudden expansion, that we can call it as isentropic expansion. Sudden compression, we can call it as isentropic compression. Here it is a compression, here it is a expansion. Okay, fine. 3 to 4. Next, 4 to 1. 4 to 1 is what? 4 to 1 heat rejection. 4 to 1 constant volume heat rejection. That heat rejection is represented as a QR. This is about what? Pressure, volume, temperature variations with respect to PV diagram, or with respect to engine operations. Okay, at the last day, students, if they asked for 10 marks, they may ask you one question: explain the working principle of Otto cycle with neat PV diagram and TS diagram, and with working schematic diagrams. If they ask such questions, that you can answer with help of this diagram here now. Initially, you can take first one. Initially, inlet valve is opened. During inlet, when the inlet valve is opened, the piston is assume that inlet valve is opened, the piston is at TDC. When piston is at TDC, it will try to move from TDC to BDC. Hence what happens now? Suction pressure is going to create inside the cylinder. Hence the inlet valve gets open. The air fuel mixture gets entered into the cylinder. Now once it's entered, right, immediately what happens? Inlet valve is going to close. That we can see now. At piston 2, both inlet and here we can see both inlet valve and outlet valves are gets closed. Then what happens now? Piston will move from BDC to TDC. So intake stroke, gasoline vapor and air fuel is taken into the cylinder. That is when TDC to BDC. You can see now 0.5 to 1. Suction takes place. Fine. Suction takes place. Now actual work will start now. So suction takes place. Hence the when the curve move from 5 to 1. Fine. Now 1 to 2 what happens now? 1 to 2 what happens now? Now piston will to move from BDC to TDC. When it is moving from BDC to TDC, the air fuel mixture is getting compressed. That compression we can call it as a adiabatic compression. Fine. Adiabatic compression where there is no heat transfer at all. For that purpose we can call it the adiabatic compression. That is done. Once it is done, then at point 2, now it reaches point 2. Point 1 to point 2, adiabatic compression takes place. At this point, what we will do, with help of spark plug, we are going to give a spark. When we are going to give a spark, that means what? You are adding certain amount of heat to the engine. You can take it as QS or QH. So you are adding certain amount of heat at constant volume, that is 2 to 3, because when it reaches TDC, right, the volume remains constant at the mixture. So that is TDC when it is at TDC. When you are going to give a spark to the air fuel mixture, then what happens now? That means what? You are adding heat to the engine. Combustion will take place. That is constant. Once it done, then what happens now? Explosive force is going to create over the surface of the piston. Hence the piston will move from TDC to BDC. That means what? Expansion is going to take place. Hence from 3 to 4, expansion is getting takes place, but there is no heat transfer from cylinder to the surrounding. That process we can call it as a adiabatic expansion. When it reaches point 4, okay, fine. Now once it reaches the point 4, then what we will do, we are going to open the outlet valve or exhaust valve. When we are going to open the exhaust valve or outlet valve, then what happens? The hot gases is coming out. That means what? Heat is removing from cylinder to the surrounding. That means what? And again at what? At constant volume. At constant volume, heat is getting rejected. That means heat loss or heat rejection at constant volume, that is 4 to 1. Okay, dear students, compression is what? 1 to 2, that is done. Combustion at there with help of spark plug, what we are doing at 2 to 3, we are doing combustion, we are supplying heat, that is 2 to 3. Next, then temperature increase from T2 to T3, that's fine. Now power stroke, when it is heat as added, right, piston is moved from 3 to 4. That means what? Expansion or a power stroke we can call. When we are going to open the exhaust valve, then what happens? At 4 to 1, heat is going to loss, or heat is lost to the surrounding. Hence what happens? Temperature decreases from T4 to T1, where T1 is what? Initial temperature of the things actually. So exhaust valve, this is what working of Otto cycle, dear students. Here this is are very important. Both heat addition is at constant volume, heat rejection is at constant volume. So this is nothing but what? Otto cycle. So okay, thank you. Dear students, I request you please subscribe my channel, do comment, do like and share and support me. Thank you very much.